Hello and welcome again, everyone. I hope you're enjoying this series. If there's any queries that you have, please let me know in the comments. Meanwhile, let's move on with our previous example that we were dealing with. So there was the concept of modularization of piece of code that we have written previously, and which is one of the important objectives of why functions come into play when we write high level code like Python or C or C++. So we can see in this program, we can see that this thing, the piece of code that is highlighted, is repetitive for each of the if and else blocks. So it's possible that we can modularize this and define this in a function of its own. So let's quickly do that now. So what we're going to do is define a function, and we're going to call the function every time you want to execute this repetitive piece of code. So let's call that function something like check for even, right? And what it is going to take is it's going to take this x as an input, because that is what we are using to determine if the number is even or odd. So what we're going to do is we could say an argument x. Right? Let's not forget the semicolon over there, and what we can do is simply take this piece of code and finally just paste it over there. Make sure that there's a level of indentation that is used, and it should be consistent throughout the function, right? And so once we're done with that, let's go ahead and let's give a call to this function here. What we're going to do is simply call the function. We are going to say check for even, and it's going to take x, right? Again. Right. So this check for even, right? We'll do several optimizations here. Now let's first try to do the simplest one, that is remove all this redundant code and write this check for even call. What we can do is remove this one too, and we're going to do check for even here as well, and same thing should be repeated down here in the else. We're going to check for even, right? That's it. Now let's just try to evaluate if this if the given program still behaves as we expect it to. So let's just quickly run it. Let's have the Python interpreter up and running. Okay, we have it. Let's give the number 12. So this should be a number that lies in 0 and 100, and that is even. So that's what we are expecting from this check for even function, right? So this is what it says: 12 lies in 0 and 100, and it is even. Let's play with another input here. Let's say 456, right? So it says that it's higher than 300 and it is even. I hope that by now it's very clear why this is higher than 300 is executed. That is because all of these three conditions at line number 9 and line number 12 and line number 15 have failed, and it has defaulted back to the line number 19, which is why it's printing that it is higher than 300. And the next statement is the function call. So it's going to take the whatever is the x value that was given by the user of the program, and it is going to pass it to check for even. That is 456 will be passed as x here, and it is going to check that if x divided by 2, if the remainder is 0, yes it is, and then that is why it's going to give us that it is even, hence the output. So let me just increase my font size here. Okay, I hope this is better. Right. So what we can do here is, if you see that, okay, let's get rid of this comment. If you can see that even this function check for even is common for all of these if else cases. what we can do is instead of I mean, regardless of which if else block is picked, the one at line number 11 or at 14 or at 17 or at 9 or at 20, right? Regardless of which of these blocks is going to be picked, it's still going to execute this check for even function. So it doesn't make any sense that it's semantically correct, but it's a better practice to not write all of these functions calls inside each of these if else blocks. Instead, what we can do is we can only write at the end of all the if else blocks have been executed. So this is in scope of the program, right? So what we can do is remove all of this, and the program is still going to behave just the same. So let's try it with the familiar inputs that we've given earlier. So let's try it with 12. So this is what it says. The program still behaves the same way. By the way, it's important to realize that the program should still behave the same way after you have done some high-level optimizations on your source code itself. Right. So with that said, we'll just make sure that our program still behaves the same. With the input 12, it says that it lies between 0 and 100, and that is equal. Right. So let's give another input 456. 56 is another familiar input that we just gave in, and it says the same thing. So the program does essentially the same thing. Let's give another input, let's say 0, and it says that it lies between 0 and 100, and it is even. Right. Alright. So I guess, but there is one important flaw in this program still, and it is that it does not handle integers which are less than 0. So let's see what's going to happen here. So if we are going to give something like -3, then what it is going to do is all of these checks are going to be failed. So the one at line number 11 and line number 13, line number 15, all these 3 checks are going to fail, and it's finally going to default back to the line number 17, and it's going to say that -3 is higher than 300, which is wrong. The program is not a correct program, and let's see why. Right. It's going to say that it is higher than 300, and it's going to say that it is an odd number. Right. So this is what it says. It says that it's higher than 300. So we'll have to take into account the negative numbers as well. So for that, what we are going to do is let's just write one check in the else block at line number 17, and you could say let's just say that if x, now what we want to do is we want to check if x is negative. We know that x is negative when it is less than 0. So if x is less than 0, then what we are going to say is let's just say that print x is less than 0. Right. So this is what we might want to write, but there are other ways of writing the program. You could have done is you could have written an if statement here before beginning with the first if statement itself. But anyways, and it's possible to write the program however you want, but it's one of the easiest ways to write it, just to handle the corner cases at the end. I feel it's much more readable over there, but it's completely up to you how you want to handle that case. So now this program is correct. Now let's enter, let's say 345, and it's going to say that it is greater than 300, and it's equal. Right. So this is what it says. 345 is higher than 300, and it is odd. Sorry, it's odd. Right. Let's give -13. Now in this case, it's going to say that it's less than 0, and it is odd. So this is what it said. It's less than 0, and it is odd. Okay. The same thing for a -3, by the way. We're going to enter it as -3 is less than 0, and it's odd. Right. Alright, so I guess this is the slightly optimized way of writing the same, and not just optimized, even more readable way of writing the same program. And it looks pretty decent now. There's a lot of clutter that has been avoided here, so it looks good. So moving on. Now, what we want to do next is we want to see how function calls can be used in the if-else clause statements. Instead of, let's say, we've captured these values here, x and y, that have been returned by this add function. So this is the program that we've seen in the previous video. If you haven't seen that one, just please go back and watch the previous one to get the context here. But this is the one that we were dealing with in the earlier video. So here what we were doing is, as I've explained it, we are going to call, or we're going to give a call to this add function, and it's going to return some value. So that value is going to be used in doing these comparisons and checks in the if-else statements. Now I want to slightly modify this one, so I'm going to get rid of this, and I'm going to say that x is less than and or equals to y, or equals to y, equals to y, right? And let's try to execute this one. Okay, so this is what it says: x is less than or equals to y. Let's try to substitute with the numbers that we're given here. Let's say x. Sorry, not the ones that we are given, but the ones that the program is going to generate for us after executing those function calls. Right, and we say the same thing here. Let's say x. Let's say x is less than or equals to y. Right. This is what it is. So let's try to execute it one more time, and it's going to say that 6 is less than or equals to 50. Right, because x is going to be 6, because it's going to take 1, 2, 3. It's going to add it here. It's going to store it into the sum variable, and it's going to return that the content at the content in the sum variable. That is 6 in the case of the call at line number 6, and it's going to be what is it? 16. Right. So this is going to be 15 at line number 7. And you then have x equals to 6 and y equals to 15, and then you're going to compare if x is greater than y, that is 6 greater than 15, that's going to turn out to be false, hence you're going to fall back to this place at line number 12, and then you're going to simply say that 6 is less than or equals to 50. Let's try it with, okay, so I'm going to try it with, let's say, I don't know, let's say 10. The reason why I picked 10 is because I wanted to see that it's still hitting the line number 12 in case where x and y are both equal. And so, yeah, it does. So 15 is less than or equals to 50, right? So in this case, it's equal to 50. So now there is one other thing that I want to mention here is what we can do is, instead of using these x and y, you may also see code from other people where you see that these add function calls are used here itself. But then, okay, how are you going to? So this is how we are going to modify it. X is less than y equals to y. And now the reason I'm removing these variables x and y is because I'm not going to have these variables x and y, and instead I'm just going to copy this entire call, or it's one and the same thing. You're going to write it here. So what I'm doing is I'm writing a call inside the if block. What I'm doing is this: writing a call inside the if block, that is 10, 2 and 3. and I'm using a comparison operator here, and I'm writing both sides. I'm writing a call because at the end of the day, the calls are going to return me an integer value, and that integer value will be compared. And we are also going to see how that is done. But for the moment, this is how we want to modify this program, and it's still going to return us that x is less than or equals to y. Right. So let's quickly glance over. Well, let's try with the modified input. And in this case, also it says that x is less than or equals to y, because in this case that it computed the result of this add, the first add with the parameters 1, 2, and 3 as 6, and so it's going to substitute 6 over here, and it's going to say that this turns out to be 15. So since 6 is less than or equal to 15, it's going to execute this line number 9. Right. So let's just quickly understand on our notebook how this piece of code executes. Right. So I'm just going to paste it here and import it. So let's see how this piece of code actually executes. So what is happening is we have a function definition here. The Python interpreter is going to say, okay, this looks fine. This is a legal Python code that has been written, and it's going to store it in the memory. Then what is going to happen is you'll encounter, the Python interpreter is going to encounter this if statement. So let's write it down, if, and then there's a add call over here, which has the parameters 1, 2, and 3. There is a greater than operator. Let's move over here a little bit, and we have another add call that says what does it say? 4, 5, 6. Right. It says 4, 5, and 6, and then you have some print statement here. Otherwise, you have some print statement here. So let's just try to see how this piece of code executes. So what is going to happen is, when you are trying to execute this if, so let's first try to understand how the if works. So in this case, it is first going to make call to this add function. Well, as we studied in the previous lecture, that it is going to have our program has something called as code memory and the runtime memory or the stack memory. In this case, the stack memory is going to be used to and one instance of this add function is going to be called, and there are going to be memory locations of x, y, and z. Let's say this is x, there's going to be some y, and then there's going to be some z. So x is going to be bear 1, y is going to bear 2, and 3 will be assigned to z. And then there's going to be some variable here, which is also going to be assigned some memory. We are going to do the computation, that is the addition, which is 1, 2, and 3. It's going to add up to 6, and then it is going to return us back the result. Now the moment it returns from here the sum variable, the Python interpreter is going to substitute this entire function call with that returned result, that is 6. And once that is done, so what we are going to do is simply erase this activation record of function call from stack memory. All of this is considered as stack or runtime memory. Now the 6 has been substituted. What about the second add function? Again, it's going to do the same thing. It is going to load an activation record or a function call. However you want to say it, it's completely fine. X will be 4. Then there's going to be some memory location y with the value 5, and then there's going to be some memory location z with the value 6. Now keep in mind one thing, these memory locations in the similar calls, like the one in the previous call which had the arguments as 1, 2, and 3, they may not be the same. These addresses may not be the same. They could be same or they could be different. Most likely they're going to be different, right? In this case, so what's going to happen is, so where we have these x, y, z variables here, there's going to be some variable that is that is also be allocated some memory, where then we are going to do the actual addition here. So it's going to be 4 plus 5 is going to be 9 and 6 is going to be 15. So that 15 will be stored back to the sum. Once we have this value 15 stored into the sum, it's going to return the value that is stored in this sum variable. So what is going to happen is this value 15 will be returned at this place. So once this value 15 will be returned, what it is going to do is it is going to write 15 over here. So it's simply going to erase that function call and write 15 over there, as if there wasn't a function call there. But as we all know, okay, so that integer 15 is a result of some function called returning a value. So in this case, then this operation becomes pretty simple for us to evaluate that 6 is greater than 15. It turns out to be false. Now then, when this turns out to be false, this piece of code inside if, that is the print statement, this print statement will not be executed and it will fall back to this else statement, which is why it prints that x is less than or equals to 1. And this is how the program is actually executed in the Python interpreter. Right. So yeah, I guess that was pretty much about doing some high-level optimizations in our source code, and then looking at how the Python interpreter is actually going to execute our program. Now let's take some more interesting examples where we use multiple function calls. Okay, right. So I'm going to define another function that says mul. This means it is going to take two variables x and y. Now please do not confuse this variables x and y and these x and y here, because they have nothing to do with each other, because these parameters x and y defined at line number 2 are private to the function mul, and they have nothing to do with the x and y that are being passed to the add function. Although, and we'll see, there's an exception to this, and it's not more an exception. It's more like think of these variables as more like placeholders and memory locations. In that case, it's going to make much more sense. So let's define our function. Let's say product. This product this is another variable that I'm defining in the function scope of the mul function itself. What I'm going to do is just multiply the two numbers x and y, store it in the variable product, and then I'm going to return, let's get this right, and I'm going to return product. Okay, so Visual Studio Code, it gives you some helpful suggestions with your variables and the functions. So that comes in handy. It also lets you avoid all the typical spelling mistakes that are involved, that are possible due to function names or variable names. Anyway, that's a convenient feature that comes in Visual Studio Code. So what we want to do is modify this add function as well, and the way that we're going to do it is what we are going to do here is we are going to do something called as weighted additions. So let this function be something called as a weighted addition. So I'm going to get a result. Let's say I'm going to write a variable temporary that is temporarily going to hold the results that I'm going to receive from the routine or the function called as mul, and I'm going to pass some constant here 10, and I'm going to pass x, and then I'm going to define another temporary variable mul. I'm going to give another call to function mul, and I'm going to say 3 and y, and I'm going to capture another variable that is local to the stack frame of add, and let's say something 5 and z. Right. Now what we want to do is return the sum of the temp1, temp2 and temp3. By the way, this is entirely legal, and it's possible that you're returning this operation from here itself instead of you could do something like sum equals to this temp1 plus temp2 plus temp3, and then you could return sum. That's also possible. It's also possible for us to simply write return temp1 or temp1, temp2 plus temp3. But since we are just at the beginning of our course, let's be more concise and be beginner friendly. In that case, we'll write the sum variable and then return the sum variable from here. Now we've made our program a bit more involved and a bit more complex because we are now dealing with multiple function calls here. Let's first understand what is the execution of this program, and then we'll see how that result turns out to be. Right. So it says that x is less than or equals to 1. Right. So let's just evaluate this entire program and see why it said that x is less than or equals to 1. I'm going to copy this whole thing and I'll just paste it here. Paste it here. Hopefully this is visible. Or let me just enlarge it. Right. Better. Now let's try to understand the execution of this particular program. The first thing is we're defining some function that is called as mul. That's fine. We've defined it. The Python interpreter has gone through each of these lines, line number 2, 3 and 4, and figured out that okay, this is a legal and a valid syntax for defining a function. It's going to do the same thing with add. Once we all know what is going at the background or when the definitions have been given a go through, because these are valid definitions. So let's say this is some area of memory which is, let's say, core memory. We're going to say core memory or static memory, whatever you want to call it. I call it usually code memory because it's used to store the function codes, the code for the actual function. Right. So then the mul function is the code for mul function is stored here, and then the code for add function is stored somewhere here. Right. Then and again, so these function definitions by themselves are not going to be of any use until and unless we are going to use them in our calls. We are going to call them through our code, right? Okay. So one more thing before we move on. We encountered there are 3 function calls at line number 7, 8, and 9. These are calls to the function mul. It's also going to check that if there is a call to a function, it's going to check if this function has been previously defined or not. So it's going to check this if this function mul has been defined, and it's also going to see that if it is indeed defined with the number of parameters that we have passed. So let's say we passed 10 and x, but then we have also included some other parameter when we defined it z, x, y, z. It means that we are expecting 3 parameters into the function, but then you're passing just 2 of them. So that's not going to be a valid Python. Right. So I mean, the valid Python code, it's not going to pass the rules of the grammar. So it's going to complain that okay, so this is not a valid Python code. Please amend it. In that case, we'll have to do adjustments in our program according to what the logic says. But in the simpler case, since we passed 2 arguments to it, and the definition also has 2 arguments, so it's going to say that okay, this function call is perfectly fine, the next one is also fine, and the third one is also fine, and the rest of the code is just simple Python code that we've seen so far. Then what is going to happen is the moment it hits the line number 13, what it is going to do is it's going to do the same thing that we've seen in the previous just right before we started with this one. But in this case, the execution of add is going to be a little bit different. So let's first see how that turns out to be. So there's a call for 1, 2 and 3. There is a comparison operator greater than, and then there is another call for 4, 5 and 6. Right. So what we are going to do is, we'll first see the execution of the first function call. So now you've seen the code memory over here. We'll see how the stack or the runtime memory operates in this case. So what is going to happen is, it is going to create the activation record with the function add, and it is going to accept variables x, y and z. It is going to say x, y and z. It's going to store 1, 2 and 3 in this. So we are currently looking at this function called x, y and z. X, y and z. So x, y and z are now going to be 1, 2 and 3. So I'm going to simply let me just write the definition of add. It's going to say, okay, let me write this one with red marker, x, y and z. What it does is, first it's going to use another temporary variable, that is a stack local variable. Now remember, these temporary temp1, temp2 and temp3, they are also going to be created in the stack, and they are going to be destroyed when the entire function execution has been completed. That is, when we are returning from line number, what is this? This is line number 11. So once we return from this point, these temporary variables are going to be destroyed. Right. So I'm going to say temp1 equals to mul of, I'm trying to do a multiplication of 10 and x. Pardon with my spelling. Mul of 10 and x. So now in this case, what's going to happen is, it sees that there is a call to the function mul, which has been defined previously in our program, and the parameters are 10 and x. What it is going to do is, first of all, it's going to do something like a memory allocation to this variable temp1. It is going to allocate some memory to store the result that is returned by the function mul, but it has not yet completed the execution of mul call, which is why it does not know what to store in temp just yet, temp1. So what it is going to do is, since it sees a call, what it is going to do is, it's going to load another activation record on top of add. It's going to say that there are two variables that are defined, x and y, in the mul. Okay, so this is how mul is defined. It takes in two x and y variables, and it has some variable called as product, which does the multiplication, stores it in this product variable, and it is going to return that product, this return product, right? So what is going to happen is, x will be 10 and y will be 1, because this x is 1, 2 and 3 for the first call. So x will be 1, y will be 2 and z will be 3. So the mul is going to accept the values as 1, 2 and 3. The mul is going to accept the value of 10, because we are calling it with this value 10, and the x is going to be taken from this add function, because we are passing values 1, 2 and 3 to this add. So x is going to be 1, y is going to be 2 and z is going to be 3. The same x is going to be passed to the mul function argument. So it's going to be 10 and 1. So it's going to take 10 here and 1 here. So x is going to be 10, y is going to be 1. Then again there is going to be some product variable that is going to be created. It's going to do the multiplication. Now again, the ALU in your machine, the hardware that actually does the multiplication, it's going to take these two integers 10 and 1, and it is going to do the multiplication and give the result as 10. And then this result 10 will be stored back into this variable 10. Once that is done, it's going to return from this point. It's going to return whatever is the value that was stored here. So now it's going to return 10. This 10 is going to be stored into temp1, right? So 10 will be stored into temp1. This is where we are going to store 10. And once we know that the function has been executed completely, we can fully ignore it, that there was a function call over there, and just treat it like that it was a normal assignment of a variable to an integer. After that, what the Python interpreter or the runtime environment is going to do is it's going to erase this function call. It's going to erase all of this function call, and it's also going to erase this temporary variable, that product, which was created in the stack frame. Right. Now temp1 has been assigned with 10. So similarly, what is going to happen is temp2 is going to be created. Another activation record is going to be created over here, which will take in x and y. X will be, I think it's going to be 3, and y will be 2. X will be 3, y will be 2. We are going to again create another product variable. The product, it's going to actually do the multiplication here. It's going to store 6 because the product is 6, and it is going to return back to another variable which will be created in the add function, that is temp2. So this 6 will be returned here. It's going to again erase. It's going to erase this activation record, and temp2 will be 6. Right? It's going to be 6 because the first argument is 3 and the second argument is 2. This 2 is coming from the one that we passed from this point. This is the point that we passed 1, 2 and 3, which is why it's going to be y is going to be 2. And same thing is going to happen with the third temp3. So I'm not going to go into the details of the execution, because we've already seen a much detailed execution of how that is going to happen with the first two function calls to 1. So we are going to get the result of 5 and 3 as 15. You already know how that is going to happen. And then what is going to happen is, let me just expand the boundary of this function call. Going to be temp3. Temp3 will store 15, and then there is going to be, again, finally there is going to be one sum variable also will be created in this activation record of the add function, sum, and it's going to be the sum of temp1, temp2 and temp3. So we are going to add 10, 6 and 15. So it's going to be what is this going to be? When temp2 and temp3 will be 21 and it's going to be 31. Right. So sum is going to be 31. So, and it is going to return sum from this point. So this sum 31, it's going to be returned here. It's going to be returned here, and this will be replaced by the value 31. Here, I'll try to say that this entire function evaluates to the value 31, and once this is done, once you've done with the execution of this entire function add, you are going to simply erase all the memory that was allocated for this add function. So that memory no longer exists. So those are not valid memory locations now. Right. So this function call has been substituted. Now the same thing is going to happen with this another add call to add function. It's going to create another activation record here. Add, it's going to say x will be 4, y will be 5 and z will be, it's going to be 6, right? And then there's going to be some temp1. I'm just going to write it as t1. I'm just going to write it as in the short form as t1, t2 and t3. So again, what t1 is going to be, so let's erase this and we'll write again the function called mul. The first one, if I remember, is 10 and x So 10 and x, the second one is, I think it's 2, sorry it's 3, it's 3 and y, and then another function called to mul will be, I think that's 5 and z. Right. That's it, 5 and z. So what is going to happen is, again you're going to encounter the function called mul in this add function. So it's going to create another activation record for the first temp1 of this second function call add. So now we are currently executing this one. Remember, we are executing this one. We've already done executing this 31. Now what it is going to do is, mul is going to accept x as 10 and y. Now remember, these x and y are completely different from the ones that are in add. The ones that are in mul are, the addresses are different. In fact, the naming of these variables, they don't really mean anything because the addresses are distinct, which is why these are not two same variables, but they're different because the addresses or the memory location or the box where we are storing these values are different, which is why the variable x inside the add function is not the same as the variable x inside the mul function, right? And y is going to be x, and we're passing x as 4, so the y is also going to be 4 here because x is passed as 4 and this 4 will be passed here as 10 and 4, right? Which is why we have 10 and 4 as arguments in our mul function, the first call to temp1, right? So then finally it's going to create another variable with the name product. It's going to do the multiplication, that will be 40, and finally it's going to return it from there and it's going to store it in temp1. So it's going to store 40 over there, right? Similarly, so again I'm not going into the details of how the second mul call is going to be executed. It's going to give us the multiplication of 3 and what is y. Y was passed as 5, so 3 and 5, it's going to give us 15. So this is 40, it's going to give us 15, and the third one is 6, z is 6, and we are multiplying 5 by 6, that is 30. That's it. So 30. And finally we are going to have, again, all of these calls will also be cleared off because this memory will be cleared off once the execution of the calls are done, right? So T1 stores 40, T2 stores 15, and T3 stores 30. I hope you understand how we've reached into these values. I mean, it's pretty straightforward at this point. Then there's going to be one variable sum that is going to be created because we are storing the addition of temp1, temp2 and temp3 into the sum. We'll do this addition. It's going to be, what is it going to be, 70 and it's going to be 85, right? Now this sum computes to be 85 and finally it's going to return the sum. So this 85 will be returned to this point. This is where it's going to be returned. 85, that's it. And then finally all of this stack execution will be removed, all of this memory will be freed because that was dynamically allocated memory by the Python runtime and the Python runtime environment. So all of this memory will be freed and we'll be left with finally 31 and 85. 31 and 85. Now we'll simply evaluate what is the answer to this one, 31 greater than 85, that turns out to be false. Once this turns out to be false, so this piece of code will not be executed and then it will say that x is less than or equals to y, right? So this is what it says, x is less than or equals to 5. Now let's try to see the program execution from the point of view of the program. So what we'll say is that we'll write some statements here to understand exactly how the program works. We'll say that x equals to, so this is useful for debugging only, sorry, not 15, it's equals to x. This is useful for debugging. I'm going to copy this, paste it. I'm going to say y equals to, I'm going to write whatever is the value of y, and z equals to z. The reason this is useful in debugging is because you can see at every point what is the value of any given variable. And we'll write some print statements here too. So print in mul. Okay, let's write in, because we also need to track which function our code is currently executing in add, which is why I'm writing the function names add and mul. I mean, you could write it as capital add or anything, because finally this whole thing is a string and it's going to be printed as it is. So it really doesn't matter if you write capital add or small add. The Python interpreter is not going to bother with it, because the whole thing is it's a string, right? So in mul, we're going to say x equals to x, and let me just copy the whole thing and paste it back, and I'm going to say y equals to y, and I'm just going to also print what is the result or the product in mul. Product equals to product. Okay, thank you. And it's simply going to return the product. Now let's also write print over here, says in add temp, or let's just say t1. I mean, it's not going to make any difference, because I mean, this is not part of the program, it's a string, so it's not a variable, which is why it's not going to complain again. But here it's important that we write temp1. So writing t1 won't work here. The reason is we haven't defined this variable t1, but the reason we are able to write t1 here is because it's a string, it's inside a string, and which is why it's going to print the whole thing as it is, and it's not going to check if it's a legal Python syntax inside the string or whatever. It's simply just going to blindly print whatever is the value of the string. Again, the same thing, I'm just going to copy the whole thing and I'm going to paste it. After the second mul call, I'm going to say temp2 and let me say t2 to avoid all the confusion. After the, okay, now here this is where I need to write it. In add t3 and temp3. Remember, temp3, temp2 and temp1 are the variables that we have defined locally to add, but t1, t2 and t3 are not variables, they're part of the string. And after we've done doing the actual operation of addition, now this is why it's this is where actually the editors and VS Code and the other editors are going to be very helpful. If you just hover over it, it's going to say that product is not defined, because product is it is not defined in the function scope of add. It is defined in mul, and add does not have any access to the code of mul, which is why it is not able to say that, which is why it is complaining that product is not defined. So what I want to do is, I'm just going to correct it and I'm going to say sum, because sum is defined in add, and vice versa. I will not be able to use the variable sum here because it is not defined in mul. Okay, right. If I just try to run this program, it's going to give me complaint that the sum variable is not defined. So let's just quickly see that. Right. Okay. It hasn't given me. Okay, so now this is interesting. Why isn't it given me? Okay, I guess. Oh, right. Why is this? Okay, built-in function. Okay, so the reason why it did not. Okay, I understand what's happening here. So the reason why it gave me this worked is because this sum variable itself is a function that is defined in Python. So this is which is why it says built-in function sum. So if I were to write, let's say I'm going to write this as capital S, and I'm going to write capital S over here, and I'm going to write capital S over here. Now it's going to complain that capital SUM is not defined because it is not an inbuilt function in it's not an inbuilt function in Python, which is why earlier it did not error out. So now in this case it's going to error out saying that this sum is not defined. And this is what exactly happened. It said that name sum is not defined. Right. So let's switch back to our original intent, that is writing product over there. Sorry, let's write product, that's fine. Right, which is why we must be careful that if there are any keywords that are defined in Python, we should be very cautious about not using them as our own variable names. Right. So now let's see the entire program execution in action. Right. Okay, there's another error over here. So between built-in function, why is this not giving? Okay, why is this not giving? Not supported between instances of built-in function method and built-in function or method. Okay, add. Is add also a built-in method? Let's just, okay, I'm just going to, okay, whatever. Let's do one thing. Let's change these names because I'm not entirely sure if these are internally defined functions in Python, but just to avoid the confusion, let's use our function naming in such a fashion that it does not disrupt the Python interpreter flow. Right. So let's use add and add. The reason I did this is because it says that built-in function. When it says that, it's most likely that a small AWT is it's also used in it's also defined in Python in its own library. So we want to be sure about the distinction between the Python defined variables and identifiers and the ones that we are defining ourselves. This should execute fine, right? So it did. Now this is how it worked out. So it says, so first we are trying to execute this add function. So it says that it's going to go over here. It's going to say in add x, y, z, and then we are going to get the 10th one, which is 10. Sorry about the interruption. So there is one quick thing what I wanted to do is simply make this code much more readable, which is why I just added this one line at line number 21. So I just added 3 new lines after going through one call of the add function. So what this is going to do is it's going to make the code much more readable. So let's just try and execute this, and the answer is not going to be any different. So if you can see that the whole thing is I think it's pretty obvious now that we've executed both the iterations of this call add, and finally what we see is that what add returns in the first call is 31 and what it returns in the second call is 85, and which explains why this print statement got executed at line number 27, because well, 31 is less than or equals to 85, which is why it did. So yeah, that was it about this video, and please let me know in the comments if there are any questions you might have, any queries, and I'll be happy to answer them. I'll see you in the next one. Thanks.